All right, so for this example, we're going to put together the cosine and sine sum formulas in one problem. This is a bit more abstract. So we won't be using our unit circle at all because I don't know what my angles are at all. But they're going to give us some definitions for these angles so we can figure out the other pieces. So when in doubt in this class, like I always love to say, you can create a right triangle. So if we know sine of alpha is 3/2, and then this will tell you where it is. Some problems will say the exact quadrant it is in, or they will give you the inequalities. So if I'm between pi over 2 and pi, remember this is 0, this is pi over 2, this is pi, and this is 3 pi over 2, and then if we go around one full, we're at 2 pi. So alpha, what that's telling me is alpha is between pi over 2 and pi. That's telling me I have to be in quadrant 2. And so I have this triangle. Remember, you're always using reference angles, so you always connect to your x-axis. Here is, I was going to give it theta, but I want to give it alpha. This is your angle alpha. Remember, our definition for sine is opposite over hypotenuse. And if you do Pythagorean Theorem, and I'm going to do this quickly because this is a good old Pythagorean triple, I'm going to get 4. But this is the main thing. Really pay attention to which quadrant you're in. So this has to be a minus since your x's are negative there. Okay, now, so I haven't even gotten to the problem at all. I'm just setting us up. Now I want to look here for my second angle, beta. They're telling us that beta lives between 3 pi over 2 and 2 pi. So that is saying it's in quadrant 4. Triangles are not drawn to scale. I'm going to get my beta here. Okay, this says that sine is -1/7. So remember, the definition of sine is opposite over hypotenuse. Your hypotenuse can never be negative because of how Pythagorean theorem works, but we're in quadrant 4, so we know this has to be negative, right? My y movements are negative. And to find this piece would be Pythagorean theorem. So this one I can't do in my head, or some of us can, but it would be, let me zoom this in a little bit. So let me change colors. We're going to get x squared plus -1 squared equals 7 squared. All right, x squared plus 1 equals 49. Take away the 1, 48. Then we have to take the square root. So don't forget, we've got to break up that 48. And that will break up into 16 times 3. The square root of 16 is 4, and 3 doesn't have 1. So your length here is 4√3. That is the most challenging part of this problem, is setting this up. Because now what you're going to do is you're going to use these definitions to evaluate what we're being asked to evaluate. So for A, it's kind of straightforward. We just want cosine of alpha. So you're going to look at alpha. Well, cosine, remember, is adjacent over hypotenuse. So that just equals -4/5. And you're done. That's a really nice one. Now B wants us to find cosine of beta. So you're looking here because this is where beta is defined. Well, once again, beta is adjacent over hypotenuse. what I'm going to do now, because I think it will get a little too messy, is I'm going to move C here and do cosine of alpha plus beta. Okay. So I'm going to refer to my reference sheet always. I personally don't even have these memorized myself. So I'm looking at my reference sheet right now, and I'm just going to write down the identity right now. It says when I have the sum formula for cosine, it is cosine alpha times cosine beta minus sine alpha sine beta. Okay, so that's just the identity that you'll always be given. And now we're just going to evaluate. Well, cosine of alpha, we're going to look here. We already have listed here. So that is -4/5 times. Well, cosine of beta, we found, but we could also look here again, adjacent over hypotenuse, minus, I wish I had us find sine of alpha and beta, but we can do it here. Well, actually, the reason I didn't, forgive me, why didn't I have us find it? Well, because they were given to us, right? But I would rather you go off this just in case you made your triangle wrong, but it's a good way to check we did our triangle right. So sine of alpha, I'm looking here, is opposite over hypotenuse. Yep, that was given to us. Sine of beta is here, which is opposite over hypotenuse, which, yep, same thing we got when it was given to us. So this is going to test some of your prior math skills with radicals and fractions. So remember, you can, it's a -4 times 4, so we get -16√3 over 5 times 7 is 35. A negative times a negative is a plus. 3 times 1 is 3. 5 times 7, 35. You can leave it like that or put it over the same denominator. And to get you in good habits, I would love you to write this at the end. Let me zoom out so I can see everything. So now let's do D. Let's do sine of alpha plus beta. So once again, I'm just going to write the formula, always looking it up. And it says sine of alpha times cosine of beta plus cosine alpha times sine of beta. I'm going to zoom out a little more. All right, sine of alpha, we know is 3/5, or we could refer to our triangle. Cosine of beta, I could look at B or refer to our triangle, 4√3 over 7, plus cosine of alpha, -4/5, and then sine of beta, -1/7. All right, well then 3 times 4 is 12√3 over 35, plus, because it's a negative times a negative, 4 over 35. And of course, I'm going to my other page. And I'm going to go ahead and I could write it all with the same denominator if I so choose. Okay. So one last thing on this video, and then we have one video after this, is we might have to establish identities using these given identities or formulas. So now we have some more information to do so with something that looks like this. So what I would like you to do, because it's very similar, So the ones that we did, let's just be clear. So example 5 looks really similar to C and D. So I want you to use that process to see if you can establish the identity. So the difference with this is they're telling you where you should end up. You just have to prove. So just like the previous section you just learned. So I'm going to leave that blank for you all to try on your own.